Encryption has found a place in today's digital world by cultivating a culture of security and privacy. Encryption has been used to secure data by governments, organizations, and other cybersecurity experts. The popular and widely adopted symmetric encryption algorithm likely to be encountered nowadays is AES, or known as Advanced Encryption Standard. Advanced Encryption Standard is one of the most common symmetric type of encryption algorithms which uses the same key to both encrypt and decrypt. It was developed as a replacement to the outdated DES, or known as Data Encryption Standard, cracked by security researchers back in 2005. This new algorithm sought to solve its predecessor's main weakness, a short encryption key length vulnerable to brute force. What is AES? AES is a 128-bit symmetric block cipher that takes 128 bits of message or plaintext, which it encrypts it into 128 bits of ciphertext with some key that can be either 128.192 and 256 bits. The size of the key determines the number of rounds involved. For 128 bits, there will be 10 rounds. 192 bits with 12 rounds, and 256 bits with 14 rounds. Note that, the larger the keys corresponding to more rounds, the more it is secured but slower encryption. To delve deeper, Advanced Encryption Standard works on a substitution permutation network, where a series of different operations are linked together and, in every round, holds 4 sub-processes. This includes subbytes, shift rows, mixed columns and add round key. For the subbytes or bytes substitution, the 16 input bytes are substituted by looking up a fixed table called sbox. Whereas the left side byte refers to the value from the row while the other one refers to the value from the column. So, the result will be in a matrix of 4 rows and 4 columns. Shift rows. Each of the 4 rows of the matrix is shifted to the left. Any entries that fall off are reinserted on the right side of row. Shift is carried out as follows. First row is not shifted. Second row is shifted 1 byte position to the left. Third row is shifted 2 positions to the left. Fourth row is shifted 3 positions to the left. Each column of 4 bytes is now transformed using a special mathematical function. This function takes as input the 4 bytes of one column and outputs 4 completely new bytes, which replace the original column. The result is another new matrix consisting of 16 new bytes. It should be noted that this step is not performed in the last round. Lastly, the add round key. The 16 bytes of the matrix are now considered as 128 bits and are XORed to the 128 bits of the round key. If this is the last round, then the output is the ciphertext. Otherwise, the resulting 128 bits are interpreted as 16 bytes and we begin another similar round. The process of AES decryption is similar to the said process of encryption in a reverse order.